Greetings, Algebra 1 students. The following is your instructional stream for lesson 3.1, graphing linear functions. So a couple of different things that we need to make sure that we create a distinction between, which is the difference between a relation, which is any time that we have a pair of inputs and outputs, versus when we have a function, showing that each input has exactly one output. So anytime we have a set of plotted points, right? And I think this is usually, my favorite way to look at this is when we see something put in a vertical table versus a horizontal table. And we're going to show all these inputs x versus outputs being y, okay? So again, we're going to have these inputs 0, 2, 4, 6, 8, 10. And then the outputs for in the input 0, outputting 0, inputting 2, output 1, 4, outputting, not 4, but we're actually going to make that output 2. 6 is 3, 8 is 4, and 10 is 5. One of the things I like about this is when we actually see it in this form, this is just an ordered pair, right? 2, 1. So we can kind of look down the line and see all those unique inputs for outputs. So this first little table we have here is what we could call a function. Versus we're going to actually create another set of inputs and outputs. It's going to be a relation, right? Where I'm just going to pair up, and I have the input 2, -4, input 2, -6. The input 3, -6, and the input 4 with an output of -8. Now here is the issue. It's that this input 2, even though it is written twice, right, it's still the same value, but it outputs multiple outputs. You can't do that, not to make this a function. So this is a relation, but not a function. Again, you have one input that cannot make multiple outputs. All right, so let's take a look here, okay? We'll play a little game, just called function or not. Oops. So here's some ordered pairs. Ready? First, we have the ordered pair -3, 1. Then we have -2, 1. Then we have -1, 1. Then we're going to have 0, 1, as well as 1, 1. Also, we're going to have a separate relation. Actually, let's work on this one first. Let's see if there's a function or not. Well, for all of these inputs, x, its first variable, do we have a unique output? And the answer is yes. There's nothing that's going to be repeated. So this here is a function. Versus, we have 1, 3, 2, 4, 3, 5, 1, 5, and 4, 6. We have an issue here, and it's this. It's not that these 5s are repeated. That's fine. You can repeat your output, but our input is repeated with different outputs. This is not a function, because 1 has 2 different outputs. It has 3 and it has 5. So that is what makes this not a function. Again, let's say we have the input x, right? And we have these outputs for y. Anytime we get multiples, in this case, -2, 0, and 4, this cannot be a function, right? Anytime this guy is doing multiple things from his input, does not make a function. Okay? Next, One of the great tests, I think, for seeing if something's a function, drawing a little coordinate plane here, and just having the first quadrant in our coordinate plane. One of the great tests, I believe, is whether or not a function passes what's called the vertical line test. So let's go and just plot some points here. So here's some points in the first quadrant. And the way that the vertical line test works is that we're going to take a line. We're going to take this guy, and we're going to pass this vertical line through the function. Now notice, every time that I am intersecting one of the points, right, going left to right, stopping, this is not touching any other point. The vertical line test means that anytime we pass a vertical line through a function, it's only going to intersect exactly once. Again, there's a unique x for every single y. Excuse me, I said that backwards. There's a unique y for every single x. So this is a function. Why? And it's because it passes the vertical line test. Let's take another look at another function here. Again, we're in this first quadrant of the coordinate plane, x and y. Okay, and we're going to take a look here at a curve. Ooh. Now here on this curve, those arrows mean that those lines are going to continue infinitely. So let's create a little vertical line. Let's see how it works. And bam, he fails. You see where this guy is intersecting in two places, right? Here and here. That is a failure of the vertical line test. So again, this would be a not. Right. Some words that we need to associate together. Anytime that we hear the word domain, we're going to read that in directions. There are two other concepts I want us to make sure that we focus on. It's the term input and x. First is when we have the term range, I want us to think output in the variable y. I want us to use all of these things interchangeably. So when we say domain, it means x and input. Or if I say output, it means y and range. Or if I say input, it means x and domain. Or if I say y, it means range and output, right? So it's just going to be one of those things that we're going to use these ideas interchangeably, okay? So we're going to find the domain and the range of the function. We'll do that for a couple exercises here. So let's create two coordinate planes. Our vertical axis, our horizontal axis. Vertical is y, horizontal is x. Vertical is y, horizontal is x. Okay, so all I need graphically from you, so let's go ahead and just move back here. Where we have, let's see, 1, 2, 1, 2 up, 1, 2 down, 1, 2 left, and I'm going to graph a series of points in this coordinate plane. So let's take this individual point right here, right? What we're looking for is to see what is the domain and the range. Now this is going to be kind of a tricky one, right? So this is my x. That's the x, that's -2. So it's going to be discrete in that I have individual points that I can identify. So -2 is one of my points. -1, right? So x here is -1. So that's another one of my points, right? 1 is another one of my points. And 2 is another one of my points, okay? Versus when I have my range, well, here, now I'm working vertically, right? So it's this guy. Well, this guy is a positive 2, right? Next one is 1. Next one of these is a negative 1, and after that it's a negative 2. So those are my defined domains and ranges, versus when I have the following. And let's go ahead and see what are all my possible x's and all my possible y's. Okay, so start here, come down here, and make a curve up to here. So this is all going to be a connected curve. All right, so domain and my range. Well, what's going to be my domain? Let's think about it. My domain is going to be all the possible x's. So it goes from here roughly to here, right? So my range is going to go from -1 all the way to a positive 3. Now, the interesting thing about that is we have a way to write in between and including, right? It would be less than or equal to. So x less than or -1 less than or equal to x less than or equal to 3, right? Because it's between -1 and 3. That's how we define that. That's what we learned in the last chapter. So we're going to take range, and it's going to be, here's our bottom, here's our top, right? The bottom is -3, the top is 3. So it's going to be between -3 and 3, and including those values, so less than or equal to -3 less than or equal to y, less than or equal to 3, and that's how we're going to write that, describe that range between -3 and 3. I was discussing with an engineer over the weekend, actually regarding astrophotography. It was a little bit not over my head, but I can speak about the mathematics of what was going on. He was referring to a formula for filtering the light, and anyway, one of the things that came up had to do with dependent versus independent variables, okay? So this variable y is dependent. The reason it's dependent is that it's going to have an outcome that is reliant on, sorry, I'm pointing to the wrong thing here, I'm pointing to the coefficient. It's going to, the y is going to be dependent on whatever we're going to put into x. Now we can put in whatever we want. When you can do whatever you want, it makes you independent. So x being anything we want it to be is independent, and whatever, depending on what that is, there's going to be an outcome of y. Independent variables. Last but not least, function c equals ct plus 8, representing the cost C for t-shirts, T plus shipping. We are going to identify the independent, dependent variables. Moreover, we're going to entertain the scenario where the domain is 1, 2, 3, 4, and 5, and we'll figure out what the range is. Okay, we're completing this problem. So for part A, what's dependent, what's independent? Well, remember, what the outcome is going to depend on what's going to be input, right? And the outcome is the one all by itself, and that's going to be C in this case. So C is independent, or sorry, C is dependent, excuse me, misspoke. Just like we had up above, right? Where Y by itself is dependent, C right here by itself is going to be dependent as well. Meaning the other one has got to be the one that's independent. In this case, the variable t. Next, our domain and our range. Well, let's go ahead and check it out. We'll have our input t, and then our output, which is c, and that in this case is equal to 6t, right? And I'm going to write this the other way around because it's symmetric, right? So 6t plus 8 is going to be equal to c. Our inputs are 1, 2, 3, 4, and 5 for our domain, right? Our domain is our inputs, in this case. The independent variable, which I have misspelled up here. Independent. There we go. And we're going to go ahead and just put that in. 6 times the quantity 1. And every time that we replace, I think it's so important, anytime that we're replacing a variable, right? When we do that, we're going to do so in parentheses. It's going to help us have fewer mistakes when it comes to our calculation and when we evaluate. So 6 plus 8, which is 14, right? 6 times 1 is 6. And then we have 6 times 2 plus 8. 6 times 2 is 12 plus 8 is 20. 6 times 3 plus 8, right? Which is going to be 26. 6 times 4. Now we do need to evaluate every single time, because as you're doing this, you may be seeing a pattern, right? 6 times 4 is 24 plus 8 is 32. And I hope you see a pattern. The reason that we can say that a pattern exists, 6 times 5 plus 8 is 38. The reason we can have it exist here is because look at what's happening, right? It's a plus 6, plus 6, plus 6. But the reason why that's happening is because our input, our domain, has a constant increase as well. So that's something that can help us identify a particular type of function that we'll be discussing in the next lesson. But for now, all we're really being asked for is this range. Well, the range is all the outputs. We have the input of 1 for our domain, 1, 2, 3, 4, 5. We input 1, we output 14. We input 2, and we output 20. We input 3, and we output 26. We input 4, and we output 32. And we input 5, and we output 38. So that is our range. Your assignment is listed in Canvas, so go ahead and get started, and good luck.